Do you guys remember we did the r theta phi x, y, z conversions and stuff? Can we all take them out, please?
Sure.
Do you guys have them out? Okay. They were very complicated and we talked about r theta phi's, right? So today we are going to attempt to find the areas and the volumes for every single one of them. So I want to start very simple. It's going to get complicated soon, so let's pay attention for today. Ready? Everybody is in or has had multivariate calculus. Raise your hands if you've never heard that word before. Okay. Two. Okay, good. All it is we will do integrations. People who have done multivariate calculus have done it in a more complicated way. We will do it in a more simple way. All I'm going to ask you to do is if we do double or triple integrals, all that means for us is that every single one of those integrals is independent of each other. Okay, so if I'm doing integration over r, I'm just doing integration over r. If I'm doing integration over x, I'm just doing integration over x. If I'm doing integration over y, I'm just doing that. And they're all being multiplied with each other. That's all that means. Okay, it's not any more complicated than that. Everybody remembers integrations, right? Like this. What is this? Plus a constant? If I do integration 0 to r of r4 dr, what's the answer? R5 divided by 5, 0 to r?
Yep.
Yes? We all remember doing that, correct? Integration of sine of theta d theta is what? Cosine of theta plus a constant. If I give you a 0 to pi, what do you do instead of a constant? You put limits from 0 to pi, correct?
Yep.
Is sine plus cosine or minus cosine? I think it's minus. It's minus.
Yeah.
It's plus when it's being differentiated, right? D over dx of sine of x is cosine of x. But when it integrates, it's the minus sign.
Yeah.
No, you're right.
All we're going to do today is we're going to put them together. So for example, our integration in multivariate calculus will look like this. R dr sine theta d theta. That's all it is. And we will give a limit from 0 to r, and we will give a limit, say 0 to pi by 2, whatever it is, whatever it may be. Got it? And what it means is you are going to be integrating them separately. You're not going to mix them up. So when you do multivariate calculus, right, you could have situations where x depends on theta and r depends on theta and theta depends on y. You know, you could mix them all up. Physics is easy. All we have to do is look at them individually. Dr, d theta, d phi, right? So that means it has a triple integral. Yes, that's all that means. And what that would mean is you will do r dr, d theta, and d phi. The limits depends on the coordinate system you're using, right? Very simple, very straightforward. There's nothing complicated in there. Thumbs up? Okay, excellent. So now we are ready to begin with our Schrodinger's cat. So the first thing I want to talk about is our coordinate system. As always, pick a coordinate system. So if my x and y are this way, where should the z point? Good. How do I show that? Good. It's a dot with a circle. Okay, I want you to take your coordinate systems and I want you to put them in such a way that they represent this vector or this coordinate system towards you, right? So your x should point towards you, your y should point towards the right, and z should point out of the paper. So put it in front of you for a second, okay? Now, where will this cat be if I give you the coordinates 2 and 3? Point on your coordinate plane where you think this cat will be. Got it? Okay, those are in x and y. Agreed? What kind of a coordinate system did we call this? Cartesian. Very good. Now, in order to do circles, you can use Cartesian systems and they become more complicated really fast. So instead of doing that, what did we say we were going to use? Starts with a P?
Polar.
Polar. So in the polar system, in the polar coordinate system, X and Y become R and phi, right? Where R limit goes from 0 to the radius R, and phi limits goes from 0 to 2 pi when we are talking about circles. Agreed? Excellent. Now, if this cat starts to move, and this cat moves in such a way that it forms a circle. Well, so this angle is theta or phi. This angle is phi. Yes? Okay. So that means if I'm looking at this picture, figure 2. This angle is still phi. If this cat moves from here to here, is this angle d phi? So remember, this could be a delta phi, right? What's the difference between delta and d? Good. So we go from delta to d in the limit when delta t approaches 0, right? In general, that's what it is. How do I define the arc? Anyone remember? S equals R phi. So a small arc will be defined as R d phi. I will forever from here on out refer to it as the sweep. So if you take your R and theta circle, guys, everybody have your circles out? So if this is my first theta, and I move this tiny box over to this box, it'll make another angle? Yes? That tiny angle will have a different point. So if this point, so I'm gonna move this down. So imagine if this point was x1, y1, what will this be? x2, y2? In this case, in polar angles, what would it be? R phi 2 and R phi 1. Make sense? So does the R stay the same in the circle? Yeah. The only thing that's changing is the angle by which it moves. And what's the total angle if this is my reference point and goes all the way around and comes back? 2 pi. Got it? So if this cat would move in a circle, what do we call that? Starts with a C, all the way around. Circumference. How do we find, what's the formula for circumference? We all know 2 pi r, right? Do you want to know where it came from? So if we move in a circle, we will call it the surface element. And how much it moves is given by ds equals r d phi. Right? That's how much the cat moved from point 1 to point 2. Agree? Now we have to find the total sweep around. How would we do that? We can integrate over our sweep. What we're doing in order to make it a complete circle is we're taking small baby steps until we come all the way back, keeping the R the same. The R doesn't change. So we are adding up all of the sweeps as the cat moves. And the sweeps are very, very tiny. And instead of summing them in calculus, we integrate. What is integration? The sum in the limit of delta being small becomes integration. When you add a lot of things, but the segments are small, you just integrate. So integration is nothing complicated. All it is you're adding up all the areas that you have. So what do we have to do on the right-hand side? Well, that is the entire sweep. And what did somebody very wisely tell me that was going to be called? Starts with a C. Circumference. So may I simply replace this with circumference, because all I'm doing is adding up all of those little elements until my Schrodinger's cat comes back. Yeah. Meow, meow, right? Comes back. Okay. And on this side, is R a constant? Can it be taken out of integration? Done. And what's the limit for d phi? What's the integration of d phi? From? Can I plug those in? What do I get? R2 pi. And we just calculated the formula for circumference. Woohoo! Magic happens. It's so cool. Are we good?